Okay, I just recorded a 30-minute video and then, Movavi starts up without your microphone activated. So I recorded the whole thing and it has no audio. So I'm going to try to run through this much quicker. And so this is just going to be a super quick because so I can check that it's working. But it's going to be a view of what it is. So this is how I program the PSOC, how I program the chip. This PSOC programmer from Cypress Semiconductor, this is a proprietary like VB6 type of thing, but it's C language. And so it has, it has a schematic of the PSOC, and then there's a top-down view. These are all the pins and stuff. This is the BLE. You add stuff on here from there. But here are the pins. See where it says PMF, TMF. Those get mapped over here onto. This is looking at the chip module from the bottom. So all of these pads, all these little things on the side, are solder points, and this is how the chip gets attached, and this is how it gets mapped into the code with this stuff on the side over here. So then that gets mapped into the code, and those functions get mapped right here. A bunch of this code got generated. I tried to, before I was mixing my code in with it, now I have all my code pretty much isolated out to HandexH and HandexC. But then they're called in these two files. HandexH is included in these two files. So there's only two files with HandexH included, and they only call a poll function. Pull the pins function. I think I have to show you something over here. Let's see, pins, HandexH. I guess that's all right. And this is where main is. So this is just the main entry point of the program. And then this calls initialize queue, which I think is in user interface or host main. So these just call, this basically just calls the other files. All this is generated by, this is the generated source that's generated by this thing, so it's kind of like off the shelf. The PSOC Cypress thing generates that for you, and then I got some other files here from a demo. This is basically, this whole project is basically a demo for making a keyboard, but I added in my two files, HandexC, HandexH, and I mapped them into those. And then, so the meat of the program is HandexC, and it basically uses this pull cord. Those other files just call pull cord. Pull cord loops through each of the pins, checks if any of them are active. So it just loops through all those ones that are mapped, reads them, see if they're active. Then if they're active, it stacks them onto a cord. And then it runs a thing that's in here somewhere, if keys active, something like that. And if keys active, if it's false, are keys active? If it's false, it drops out of the loop and it sends the keystrokes. So it goes down to this, get the key from the cord. So when the keys are down, you're just adding, you press another finger, you add that to the cord. You press another finger, you add that to the cord. This is what a cord map looks like. And these are from the other CSV file. So this whole thing is too complicated to edit every time you want to change something. So that leads me over to my other code. My other code is over here. This these couple of projects, okay, it's basically this project, key sequences. Key sequences has this mapping CSV. And so this CSV, if we want to change any characters, we just use the key sequence in here. We just know that the fingers are numbered from thumb to pinky and from fingertip to palm. So the thumb is 0, index fingertip is 1. That's this one right here. And then it's 2, 3, 4 to the pinky fingertip. So this one right here is pinky fingertip. Then the second one is on the second line, second character there. So that's 7. So the second row is 5, 6, 7, 8, 9. So 7 is middle finger grip action. And then the pullback actions are A, B, C, D, E. And that's for this chord, for these yellow characters. So anything in here is hexadecimal finger actions of the hand. So 9 would be pinky grip, 4 would be pinky tip, and 6 would be index finger grip. So that's probably a little long of a stroke sequence, but that's because it's a number. And so the numbers are a little difficult right now. We'll fix those by remapping. This is where we'll remap them. Once we change them in here, we go over, this is the program that runs it. This is in JavaScript right now, make keys. It's not very long, but it relies heavily on a thing called maps, which is some other JavaScript code. And these are just a bunch of little functions that do maps. Some of them are outdated. This goes back to a time when I was wiring things up with pins, with wires. I had to keep track of the color of the wires and which pin on a board it had to be plugged into and soldered onto. So that took a lot of effort, and some of that is still in here. I'm going to try to clean it out. But the way that's called is by a PowerShell module, which is right here. And so I have this loaded on my thing just by running this right here, running Handex. I get all of these functions right here, and then I can just run the make keys from the command line. And the PowerShell creates all the SVGs also. So it maps the little glyphs onto the SVGs. A couple of hundred SVGs get put out into the HandexCodeMapping website. So every time this file is edited to change which key is mapped to the output character, or I should say which finger actions are mapped to the output character, we just have to run make keys PowerShell program, and that will generate the if ladder over here. That'll regenerate this whole if ladder, which gets programmed onto the PSOC chip, but it will also create all the SVGs for the finger actions that are on HandexCodeMapping. It'll remap all those. So that is the whole program, and I'm under 10 minutes. Anyway, hope this helps. Uh, I'll have other supplemental videos where I talk about mapping the right keys to the right, for Vim compatibility, to make it memorizable which keys are mapped to which characters.